Welcome to this platform. So in this video we're going to look at travel graphs. We're going to look at the travel graphs. So now this is an important topic in mathematics where paper 1 is concerned. So you need to understand it very well. Okay, so for the sake of our learning, we are going to use this question. And what is the question? The diagram below shows the speed time graph of a particle. The particle started off from rest and accelerated uniformly for 10 seconds. It then traveled at a constant speed for 20 seconds and then decelerated to rest. The first question is find the speed v the particle reached if its acceleration was 2 meters per second square in the first 10 seconds. Find the speed v the particles reached or the particle reached if its acceleration was 2 meters per second in the first 10 seconds. So this is the speed v we are finding here. How do you find the speed? So in this one we are going to consider the formula that we can use to find speed given the acceleration and of course the initial speed. We can find it there. So what is the formula that we need? So the formula that we need is acceleration is equals to final speed minus initial divide the time taken. Now let us collect the data that we have here. So what is the data that we have? In the question we have acceleration which is 2 meters per second square. Then we also have initial. The question says it started from rest, so automatically the initial is 0 meters per second. And now what else do we have? We have time. Time, it was given that in the first 10 seconds. And now what we are finding is the final speed, which is v. Okay, so this one we put a question mark. Now, having this information, we can replace in the formula. What are we going to do? So where there's acceleration, we put 2. So 2 is equals to final velocity, initial we know is 0, divide time, which is 10. So here we cross multiply. This on top will just remain v, which is equals to 10 multiplied 2 is 20 meter per second, and this is the speed v that is in the first 10 seconds. So that is how you calculate it. So we can replace it here 20. Okay, 20 since it's already meter per second here. Okay, what is the second question? So the second question is find the distance traveled in the first 10 seconds. Find the distance traveled in the first 10 seconds. So there's just something that I need to bring out here, is that the speed time graph tells the story about the motion of the object, and the area formed under the speed time graph, I mean the shape formed under the speed time graph, finding its area, you are finding distance. So what I'm trying to say is that area under the speed time graph is equals to the distance. Now since we are told in the first 10 seconds, so we are going to find the area in the first 10 seconds. And how do we do it? We are going to find the area of the shape formed. And what is the shape formed? The shape formed, if we are to look at it, is a triangle like this. That is the first 10 seconds. Here is 0, here is 10. And of course here, if you look at the velocity, the one that we've just calculated is 20 here. So it means this part is 20. Okay, so in order to find the area, we are going to use the formula for a right angle triangle. So area, which is distance, so we are going to say distance is equals to half base times height. Now what is our base here? It is from 0 up to 10 here, which is 10. Then what is our height? Our height is the vertical one, so our height is equals to 20. So replacing in the formula, we are going to have, that is the 20, or let me start with the base, that is 10 multiplied by 20 divide 2, which is this 2. So what are we going to have here? We are going to have 200 on top there, 200, which is divide 2, we are going to have 100. So this is 100 meter. That is how we find the distance. So we found the distance of this triangle. That is how we find the distance under the speed time graph. Okay. Now what is the second question that we are, or the third question that we are answering? The third question that we are answering is calculate the distance covered in the first 30 seconds. Calculate the distance covered in 30 seconds. Now how do you calculate the distance covered in the 30 seconds? We know already that the area under the speed time graph is equal to the distance. But this time around is from 0 up to 30. Now we need to look at the shape formed also. In the first 10 seconds, we said this one was a triangle, right angle triangle. What about in 30 seconds? So we have the whole of this shape. What shape is this? So now this is the trapezium. Okay, the trapezium is just a shape with two parallel sides. So these sides are parallel. Okay, so how do you calculate the area of the trapezium, since we know that the area is just the same as distance? So let us just redraw this shape, and it is like this. Okay, so now finding the area of the trapezium, area is equals to half, that is half a plus b times height. This is the formula that we use. If you want, you can write it in this form: a plus b times height divide 2. Okay, now which one is a, which one is b? So we have two bases here. We have this one, we have also this one, we have this one, also we have this one. So please, whichever you choose to put a or b, it doesn't really matter. Okay, so we are going to choose to put this one b and this one a, and which means this one is the height. Let us find now the distance of the whole shape, because the whole of this shape we were saying is a trapezium. Now in finding the distance, still we are going to apply the formula. So distance is equals to half a plus b, then multiply height. What is our a? We said our a, we are going to choose this one, and this one is our b down here. Now in this one, a start from here up to here. So we are going to find the difference between the two numbers, that is 30 and 10. And the difference, if we are to subtract 10 from 30, you find that that is 20. So distance is equals to half, okay, half, then our a we said is 20 plus, what is our b? So our b is the whole of this one from 0 up to 30. So our b is 30, okay, times what is our height? So the height is from the distance between the two parallel sides. So from here up to there, which is the one that we found, which is 20. So I'm going to just fix 20 there. Let me just relight it nicely here. So let me just create some space. Okay, so it's going to be distance is equals to half, that is 20 plus 30, then multiply 20, that is the height. So calculating the distance here, we are going to have this one, 2 into 2 is 1, 2 into 20 is 20. We work out the brackets first. So 20 plus 30 gives us 50. Okay, so distance is equals to 50 multiply 10, and therefore the distance is going to give us 500 meters. So that is how you find the what? The distance. Okay, now what is the other question that we need to find, or that we need to calculate from this one? The other question is that calculate, let me start with calculate the total distance of the whole journey. Calculate the total distance of the whole journey. So for the sake of this question, I'm going to put a temporal number here, which is 40. We are going to come back to calculating t, but let me just put 40 here for the sake of something that I have to explain. Okay, if you're asked to find now the total distance of the whole journey, how do you find the total distance? So please, finding the total distance, you are going to consider the whole shape that is formed. Okay, so we said in the first 30 seconds, we said this is a trapezium, but also the whole of this one is also a trapezium. That is from 0 up to 40 here, and also the whole of this is a trapezium. Now, how do you find the distance? So you're going to consider this shape, the whole of this. Okay, this is the trapezium. So this is starting from 0 here, and this is, I said I'm going to put a 40 for the sake of explaining. So now, finding the total distance, we are going to find the area of the whole shape. We are going to use distance is equals to, since it's a trapezium, a plus b multiply height. So now, what is our a? So now here there's a number we are going to maintain 10. Here there's 30, we maintain it. Okay, and here I found 20 here. Okay, so what is our a? So we said our a, we are going to put this one, and b this one. So now a we said is 20, so we are going to say 20, then plus our b, so half. Our b, we said b is the whole, this time around b is the whole of this one. So from here up to 40 there, that is our b, so plus 40. Then what is the height? From here up to there, it's 20, so 20. This one cancels, this one cancels. This is 10. This is 10, and also okay, so this is 10. So distance is equals to 20 plus 40, we have 60. Okay, multiply by, let me just say multiply by 10. So this one is going to give us 600 meter as our total distance. So if you are given such a shape, please just consider this one is a trapezium. So that is the formula that you use. Okay, so this knowledge that I've just explained is going to help us to find t. This is something that is going to help us to find t. Okay, so which means the next part, the next question that we are answering is that given the total distance covered, or given that the total distance covered was 750. So the total distance covered this time around was 750. Remember I said I'll just put a 40 there temporarily. Okay, so back to the question. So the total distance covered was 7. So total distance covered was 750 meter. Then now the question is that find the value of t in the diagram. So you are going to find the value of t, this t, in the diagram given that the total distance covered is 750. How are you going to find the total distance? So this is how you are going to do it. So total distance, you are going to write total distance. We are going to use a formula for a trapezium, since the whole of this is a trapezium. So you are going to say total distance is equals to half a plus b multiply height. Okay, let us fix in what we have. So what is our a? So our a we are still going to maintain is this a, and this is our b. Okay, so now the b we know that is from 0 up to here where there's t. So simply we pick this t. Okay, so now our b is equals to t. Our a is equals to 20. Okay, so now our height is equals to 20 as well. So fixing in the formula, we are going to have distance is equals to half a. Our a, we are going to have a 20 plus our b is t. Then height is 20. We can cancel this and cancel this. This one remains 10. This one goes. Okay, distance is equals to, in the brackets, we have 20 plus t. But outside here, there's a 10. So we are going to multiply. So please, let me also, where there's d, let me replace 750 at this point because we are given the total distance. Okay, so in the brackets, we are going to open the brackets by multiplying the 10. So 10 multiplied by t, we are going to have 10t. Then this one is going to be 200. So we are going to have 200 plus 10t is equals to 750. So what are we going to do at this point? We collect the like terms. So we are going to have 10t is equals to 750 minus 200. Okay, let me just clear the top part here. And when we subtract there, you know that it will give us 10t. It is going to give us on that side where we subtract 700 or 750 minus 200 to give us 550. Okay, then this side you are going to remain with 10t. We want to find t, so divide 10, and therefore our t is equals to 55. So the time is 55 seconds. That is how you find it. Okay, so that is what we needed to do in this question. Alright, so we offer intensive online tuitions. If you are interested, you can get in touch on the line 0976 402563. What are the subjects on offer? So the subject on offer, we have physics, we have mathematics, we have chemistry, we have biology, as well as civic education. So please note that the lesson that we offer are exam oriented, or rather we give intensive, we offer intensive online tuition. So if you are interested to register, you can just contact me on the number 0976, that is +26 0976 402563, and we'll be waiting to service your academic needs.